Hello everyone, in this video we will talk about the Lewis structure of chlorate ion. To write the Lewis structure, we need to count the total number of valence electrons in the molecule, and we know that atomic number of chlorine is 17, and therefore the electronic configuration is neon, that has 10 electrons, and then 3s2, 3p, 5. So this means chlorine has 7 valence electrons. We have only one chlorine atom, therefore that is equal to 7. And then oxygen atomic number is 8, therefore the electronic configuration is helium, that is the core, and then 2s2, 2p, 4. So we have 6 valence electrons in oxygen, but we have 3 oxygen atoms, so therefore 3 times 6 equal to 18. And then for the negative charge, we need to put 1 electron. This is for the negative charge, and therefore 7 plus 18 plus 1. This means that we have 26 valence electrons in the chlorate ion. Now let us write the Lewis structure of chlorate ion. We know that chlorine is less electronegative compared to oxygen. Therefore chlorine comes at the center, and then we put 3 oxygens around it. Let us put one bond pair between each oxygen and the chlorine atom. That accounts for 6 electrons. And then let us put 3 lone pairs around each oxygen atom. That would account for 3 times 6, 18 valence electrons. So 18 plus 6, 24. We still have 2 more valence electrons. Let us put that on top of chlorine, because in total we have 26 valence electrons in chlorate ion. Now you might think that this is the best Lewis structure for chlorate because each atom obeys the octet. All the oxygen atoms obey the octet configuration, and the chlorine atom also obeys the octet configuration because it has 8 electrons around it. However, this is not the best Lewis structure for chlorate ion. Let us calculate the formal charges to see why it is not. Formal charge is equal to total number of valence electrons in the atom minus total number of non-bonded electrons, that is the lone pairs of electrons in the molecule, minus total number of bonded electrons by 2. So therefore if we calculate the formal charge for chlorine, we have 7 valence electrons in chlorine, and the lone pair we have is only one lone pair, therefore 2 here, minus we have 3 bond pairs, the one shown in yellow. So that means 6 electrons, therefore 6 by 2. So this means 5 minus 3, and that is equal to plus 2. Therefore we have to put a plus 2 formal charge for chlorine. How about oxygen? If we calculate for oxygen, then it would be 6 valence electrons minus each oxygen atom has 3 lone pairs. So therefore 6 minus we have 1 bond, and therefore 2 by 2. So this means minus 1. So for each oxygen atom, we have to put the formal charge as minus 1. Even though this accounts for the net charge, because plus 2 minus 3, total we will get minus 1. This is not the best Lewis structure, because in the best Lewis structure, the formal charges has to be close to 0, so that the structure will be most stable. Therefore, let us bring 2 lone pairs to the bond pairs from 2 oxygen atoms, so that we can reduce the formal charge of chlorine as 0. Now if we write a Lewis structure like this, chlorine having a double bond with the oxygen, and then 2 lone pairs, and then at the other end also having a double bond with the oxygen, and then 2 lone pairs, and then the central oxygen atom having a single bond with the chlorine and having 3 lone pairs and 1 lone pair on top of chlorine. Now if we calculate the formal charge of chlorine here, we would get 0. But before calculating the formal charge, For this structure, you might be wondering how come we are having 12 electrons around chlorine, because 5 bond pairs plus 1 lone pair, so we are having 12 electrons around chlorine. Keep it in mind that chlorine belongs to period 3. Just like sulfur and phosphorus, chlorine can also adapt to extended octet configuration. The oxygen atom still be obeying the octet configuration, but chlorine atom can adapt to extended octet configuration. Therefore, having a structure like this is totally valid. Now let us calculate the formal charge for chlorine. Formal charge for chlorine atom will be equal to, we have 7 valence electrons in chlorine, minus we have 1 lone pair, therefore 2, minus we have 5 bonds, therefore 10 by 2. Therefore, this will be equal to 5 minus 5, and that is equal to 0. Therefore, the formal charge of chlorine here is 0. How about oxygen atom that is having double bond? Let us calculate that first. Therefore, for oxygen atoms, it would be, we have 6 valence electrons in oxygen. For the oxygen that is having double bond, we have 2 lone pairs, therefore 4 here, minus we have 2 bonds, therefore 4 by 2. Therefore, this will become 2 minus 2, that would be equal to 0. And if you calculate the formal charge for this oxygen atom, then it would be 6 minus, we have 3 lone pairs, therefore 6 once again, minus we have 1 bond, 2 by 2, and that is equal to minus 1. Therefore, for this oxygen atom it is minus 1, and for these two oxygen atoms it is 0. That accounts for the net charge minus 1. This is the best Lewis structure for the chlorate ion. And the reason is we can have resonance contributions, because one can also write structure like this. Chlorine having a double bond with the 2 oxygen atoms. So instead of putting the central atom having the single bond, now we are putting the single bond on the right hand side. So we can write like this, or we can also write like that, where chlorine on the left hand side, let's say with the oxygen atom, it is having a single bond, and then with the other 2 oxygen atoms, it is having a double bond. Because we can write resonance contributions, this is the best Lewis structure for chlorate ion. Always remember that the closer the formal charges as 0, the most stable the structure will be. Also, since it is an ion, we need to put brackets around it to show that it is an ion with the net formal charge as minus 1. Whenever you are writing the Lewis structure for cation or anion, you need to put square brackets and you need to put appropriate charges around it.